Okay, in lesson 12, we're going to be looking at some more real life examples of looking at similarity between triangles. So if you look at the first problem there on your note sheet, it says, not all flagpoles are perfectly upright, which means they're perpendicular to the ground. Some are oblique, which means they're not parallel or at a right angle. It means they're actually slanted, like right here in the picture. So imagine an oblique flagpole in front of an abandoned building. The question is, can we use the sunlight and shadows to determine the length of the flagpole? So, first question down here says, assume that we know the following information. The length of the shadow of the flagpole is 15 feet. So I'm first going to mark that. So if we say the sun is right up here and to the left, then my shadow is going to be right along here. Okay, so I'm going to draw in, let's say this is the shadow right here. Okay, and I know that the length of that is 15 feet. So I'm going to go ahead and label that 15 feet. Okay, now, next thing it tells us is that there is a mark on the flagpole, so here's my flagpole, 3 feet from its base. So I'm going to put a little mark right here. And I know that that is 3 feet from the base. So I'm going to mark this little section right here, 3. Okay. Now, the shadow of this 3 feet portion of the flagpole is 1.7 feet. So, whatever this little mark, pretend the sun's coming from this direction, it's going to fall right in here. So if I just go ahead and complete this triangle right here, okay, I know that my distance right here, that line, is going to be 1.7. So I'm going to go ahead and label just this little section right here 1.7. So our whole question with this is, can we determine the length of the flagpole? Can I determine this whole line right here? Well, to do that, I'm going to go ahead and complete a second triangle here. Okay, and these two lines that are parallel right here, those are like the sun's rays coming down from up here to complete those triangles. So we have the length of the flagpole here. We have the little mark on the flagpole that is 3 feet from its base. We have the length of the shadow of the entire flagpole is 15, and we have the length of the shadow of that just 3 foot portion right there as 1.7 here. So what they want to know is, can we figure out the length of the entire flagpole? So first thing we need to do is figure out if these triangles are corresponding or not. And as the first thing, I'm going to write in here is that yes, they are similar because of the angle-angle criterion. So how I knew that is they both share this angle right in here. And then since these lines are parallel, that means that the corresponding angles are congruent. So I have this angle right here, and then actually both sets of angles on the bottom are congruent. Both sets of angles right here on top are congruent. So angle-angle tells us that they are similar. Now we just need to figure out next what the scale factor is. So to find the scale factor, you divide your two lengths. So I'm going to divide 15 by 1.7. And when I do that, I end up getting, I'm going to round it to the nearest tenth, so about 8.8. Okay, so I know my scale factor is 8.8. So now, if I want to know this entire distance of the flagpole, all I do is take the 3 and multiply it by 8.8. So 3 times 8.8, and when you work that out, you get 26.4. So the height of that slanted flagpole is 26.4 feet. Okay, moving on to the next exercise. It says you want to determine the approximate height of one of the tallest buildings in the city. You are told that if you place a mirror some distance from yourself so that you can see the top of the building in the mirror, you can indirectly measure the height using similar triangles. So they say, let O be the location of the mirror. So here's our mirror right here, so that the person shown can see the top of the building. So here we have our diagram. Here's our building over here on the right. First of all, part A wants you to explain why triangle ABO, so that's this little one, is similar to STO, so and that's the big one right here. So I have no information of lengths of sides given to me. So the only thing I can really try to figure out is if there are any angles that are, any corresponding angles that are equal. And the first thing I notice right here are these 36s. And if you look, those are corresponding angles. And so there's one set of angles that are congruent. And if I look, I don't know about the measure of angle A and angle S, but what I do know, angle T would be a right angle. And where the person's standing, angle B right here would be a right angle. So I know two sets of angles that are congruent. So based on the angle criteria, we're going to say that those are congruent, or I'm sorry, similar. So for part A, we'll say yes, triangle ABO is similar to triangle STO because of angle. The triangles have two sets of corresponding angles that are equal. And then I'm going to go ahead and name those. So that was angle O equals angle O prime, which they just have O, so just know that we're talking about the two different triangles there. Those equal 36 degrees. And angle B equals angle T, which equals 90 degrees. And I apologize for making this font so small, so we'll make it a little bigger there so you can see. Okay, so we just proved that these two triangles are similar because they have two sets of angles that are corresponding, therefore they're equal. So we had the two that are 36, and we had another set, the two that were 90. Okay, then moving right along to part B. It says, label the diagram with the following information. So, the distance from eye level straight down to the ground is 5.3 feet. So that's going to be your height right here with the person. So I'm going to label that 5.3. Okay, the distance from the person to the mirror is 7.2 feet. So that's going to be right here along BO. So 7.2. Next, the distance from the person to the base of the building is 1,750. So from B all the way to T, this part is going to be 1,750. And I'll make that a little bigger so that we know that it goes all the way across there. And the height of the building will be represented with X. So there you go. We're trying to figure out how tall the building is. So part B, that's all they wanted us to do, was to label the information that they give you. Part C actually wants to know what is the distance from the mirror to the building. So pay attention to what they're asking. This one, they're not asking you to find X. They just want to know how far is it from the mirror to the building, from O to T. So all we need to do right here is take the entire length, which was 1,750, and subtract the little distance from the person to the mirror, so 7.2. And when you subtract that, you get 1,742.8 feet. Now, you don't have this part on your note sheet, but what I want to go ahead and do, and you can do this over to the side somewhere, is now figure out what X is. How tall is that building? So we've already determined that the triangles are similar. So if we can do this one of two ways, you can either determine the scale factor by dividing, or we can set up a proportion, which personally I think may be a little easier. We did this a little bit last year, setting up proportions. So you're going to set up ones that are corresponding to each other. So if I take the height of the person, 5.3, and I'm going to put that over how far it is from the person to the mirror. And then I'm going to set that equal to what corresponds with those two sides on the bigger triangle. So what corresponds with the height of the person? Well, that would be the height of the building. So I need to put that on top. And then what corresponds with the distance from the person to the mirror? Well, that was just this distance from the mirror to the building, not the 1750. This will be the answer that we just found. So 1,742.8. Okay, remember when you have a proportion, you cross multiply. 7.2 times x is 7.2x. And then when I multiply these other numbers together, 1,742.8 times 5.3, you get 9,236.84. Okay, final thing I need to do is divide by 7.2 to get that x by itself. Do that on each side. And when I do that, you get a great big long number. I'm going to round it to the nearest whole number. I get 1,282. When I round that, you get 1,283. So that's how tall your building is. Okay, this completes the notes that we have for lesson 12. So now your assignment's going to be to do the problem set for lesson 12. We will go over that tomorrow along with your study guide, and your test will be on Monday.